Alright, another quadratic that is a bit special to factorise. What we're going to be factorising today is when a quadratic, say in the form ax squared plus bx plus c, where a, b and c they're just standing in for numbers, we're going to be factorising today when that a term, the term in front of x squared, doesn't equal 1. Okay, well, how are we going to do this? Hopefully you're pausing the videos at moments like this and having a bit of a think and having a go first. I do tend to just jump in a bit quick. So what we want to do is we could see what's special about 2, 10 and 12. They do have a common factor of 2. What would happen if I brought the 2 out of all 3 terms? 2 bracket x squared plus 5x plus 6. Interesting. So taking the 2 out has left me with a simple quadratic. Well, hopefully you know how to factorise x squared plus 5x plus 6. We know we can put this into double brackets. So leave the 2 out the front, double bracket, we have x plus 2, x plus 3. Great, so that's not actually too bad to factorise because there was a common factor in all the terms. That could come out and then the rest was quite easy. Why don't you give the second example a go? 5x squared minus 15x minus 20. Do they have a common factor? Does 5, negative 15 and negative 20 have a common factor? It does. 5, and for these simple ones it usually is just the number out the front. Leaving x squared minus 3x minus 4. Well, that's a simple quadratic. Keep that 5, double bracket, x minus 4, x plus 1. Not too bad. I kind of colloquially call that the pretender. I call it the pretender because it's just pretending to be a hard factorization because there's that number out the front. So in A11, those are the pretender because they're not actually too bad. So maybe make a note of that. Give these 8 a go. I've given a wee bit more room to do 7 and 8, so hence the scribble there. So pause the video on those and give them a go. Okay. First question, we have 3x squared plus 21x plus 36. Do those numbers share a common factor? You'd hope so, since this video is about, the pretender. So a 3 can indeed come out, leaving 3 out the front, bracket x squared plus 7x plus 12, close bracket. What's left inside is a simple quadratic. So if you get the 3 coming out wrong, here's another 8 at least factorizations you could practice when you see the number that I take out. That's going to be a double bracket of x plus 3 and x plus 4 because they multiply to 12 and they add to 7. Question 2, 4x squared minus 20x plus 16. We've got a 4 coming out of all those terms, leaving x squared minus 5x plus 4. Simple quadratic has been left on the inside. Keep the 4, double bracket. We have x minus 4, x minus 1, because those two numbers multiply to positive 4 and they add to negative 5. Question 3, 2p squared plus 12p minus 110. That 110 is a big number, but when we take the 2 out, all of that's going to get reduced. I'm just using p to show you that it might not always be an x squared. It's good to get used to seeing other variables. So 2 comes out, we're left with p squared plus 6p minus 55. When I see 55, I straight away think 5 and 11, and indeed that is going to be the number to give me 6. So 2, p plus 11, and p minus 5. Had to think about that for a second. Question 4, 3x squared minus 24x plus 21. Yep, all got a factor of 3. 3 comes out. X squared minus 8x plus 7. You've got to be careful. You want to make sure you get that one right. It's easy to make a mistake there, so I was being careful on that 24. 3, double bracket, because it's now a simple quadratic inside here. We have x minus 7, x minus 1. Because they times to 7, they add to negative 8. Question 5, 2k squared minus 8k minus 10. 2 comes out, k squared minus 4k minus 5. 2, double bracket, it is a k minus 5, k plus 1. Since they multiply to negative 5, add to negative 4. Next one, a 4 can come out of all these terms, so we've got a 4p squared minus 32p minus 36. 4 comes out, leaving p squared minus 8p minus, what's that going to be, 9. Simple quadratic left on the inside. We have p in both brackets, and it is negative 9, positive 1. Negative 9 times 1, negative 9. Negative 9 plus 1, negative 8. So it indeed does work. Okay, question 7. I've got 2 special ones here. I've got 3x squared minus 30x plus 75. The 3 can come out of all those terms. X squared minus 10x plus 25. Hopefully that looks familiar from previous video. That is, I believe, a perfect square. 3 times, in brackets, x minus 5, times, in brackets, x minus 5. Got the same thing twice, so we write that as 3x minus 5, and it's squared. So the x minus 5 is squared. Not all squared, because we took that 3 out first, and then found the perfect square. Question 8. It looks like a difference of 2 squares, but no whole number squared is going to give 20, and no whole number squared gives 5. However, we can see that there is a common factor. I might write that down again. Common factor, and it's 5. So the 5 can come out, leaving 4x squared minus 1, and that is now a perfect square. We have 2x all squared and 1 squared, so yeah, difference of squares. So 5, 2x minus 1, 2x plus 1. There we go.